Week 3 was on inductance in AC circuits. It's Unit 17 in the 6th edition. Number 1, how many degrees are the current and voltage out of phase with each other in a pure resistive circuit? The answer is 0 degrees. They're actually, the current and voltage are in phase. Number 2, how many degrees are the current and voltage out of phase with each other in a pure inductive circuit? And that is 90 degrees. Current and voltage are 90 degrees out of phase in a pure inductive circuit. Number 3, to what is inductive reactance proportional? The answer is inductance of the inductor and frequency of the applied voltage. The formula, this is inductive reactance, equals 2 pi FL. 2 is 2, the number 2. Pi is the number pi, that's 3.14. F is the frequency of the inductor, or of the applied voltage, excuse me, and L is the inductance of the inductor. Four inductors, each having an inductance of 0.6 henries, are connected in series. What is the total inductance of the circuit? So we have 4 inductors at 0.6 henries each. So we simply add them up. We can multiply the 0.6 times 4, and we end up with 2.4 henries. That's the same as 0.6 plus 0.6 plus 0.6 plus 0.6. Number 5, 3 inductors are connected in parallel. Inductor 1 has an inductance of 0.06 henries, inductor 2 0.5 henries, and inductor 3 0.1 henries. What is the total inductance of this circuit? Let's draw the circuit quickly here. AC voltage source. We have 3 inductors in parallel. Sorry for the bad drawing. This is L1, this is L2, this is L3, and we have the values of those inductors up here. And so total inductance LT equals 1 over L1 plus 1 over L2 plus 1 over L3. And if you do the math, it's 0.0214 henries. Number 6, if the 3 inductors in the previous question were connected in series, what would be the inductive reactance of the circuit? Assume that inductors are connected to a 60 Hertz line. So now I'm going to draw it down here. We have the 3 inductors in series, and they're looking for X sub L total, the total current limiting thing of these 3 inductors. We know that inductive reactance equals, well, it equals this formula right here. So we need to find total inductance to plug into that value right there. In series, total inductance equals L1 plus L2 plus L3. And that amount is right here. I just simply added them up. I plug that number into the formula, and the final answer is 79.2 ohms. Remember, inductive reactance is a current limiting thing, and it's measured in ohms. Number 7, an inductor is connected to a 240 volt 1000 hertz line. The circuit current is 0.6 amps. What is the inductance of the inductor? So the question is asking for inductance of this inductor. So draw the circuit. L equals question mark. This is 240 volts at 1000 hertz. And the current flowing is 0.6 amps. So we're basically going to use Ohm's law here. So I'm going to redraw the formula. So this is basically Ohm's law. Instead of resistance here, we're solving for inductive reactance, the current limiting thing. So 240 divided by 0.6 gives 400 ohms, and that's what we can plug into our formula. We need to do a little bit of algebra. We know this is the formula for inductive reactance, but we're looking for inductance. So I'm going to draw it, or rewrite the formula up here, solving for inductance equals x sub L over 2 pi f. And if you do that math, that's right here, we get a final answer of 0.0637 Henry. Number 8, I'm just going to go straight to the circuit here. So L equals 3.6 Henry. We have 480 volts, 60 hertz. And the question is asking for current equals what? So we have our formula here for inductive reactance. If we do this math, we get this number right here. So x sub L equals 1357.2 ohms. That's using this formula here, the formula that we've been talking about a lot. And then now I'm using Ohm's law. And I'm substituting inductive reactance for resistance in Ohm's law. And that's 480 divided by 1357.2. That equals 0.354 amps, or 354 milliamps. Number 9, same circuit, but the frequency is reduced to 50 hertz. So we have 3.6 henries, we have 480 volts, we now have 50 hertz. And just doing the same thing we did in the last problem, but now we're using 50 hertz in this formula. This gives a little bit less inductive reactance. And then again, we're using Ohm's law, substituting inductive reactance for resistance. That's this math here, and it yields 424 milliamps. There's a typo in number 10 in the 6th edition. The question reads, an inductor has an inductive reactance, so inductive reactance of 250 ohms. It should be ohms. In the 6th edition it says volts. It's connected to a 60 hertz line, and they're looking for what is the inductive reactance if it's actually connected to a 400 hertz line. So circuit inductive reactance equals 250 ohms. We have a 60 hertz line, but we're increasing that to 400. So the way we solve it, we have x of L equals 2 pi f L. We're given x of L, that's 250 ohms. We're given frequency, that's 60 hertz. So what we need to do is solve for L equals x of L over 2 pi f equals 250 ohms over 2 pi 60 hertz equals this value here, 0.663 henries. Now we're raising the line frequency up to 400. We go back to this formula, and now this value is going to be 400. So the new inductive reactance, the new x of L, is going to be 2 pi times f, which is 400 hertz, times the inductance that we solved for in the first step, and that equals 1667 ohms, or 1.667 k ohms. This, by the way, is wrong. Right here, this should be x of L, and this should be ohms. Number 11, an inductor has an inductive reactance of 80 ohms and wire resistance of 14 ohms. What is the Q, or the quality, of the inductor? Quality equals inductive reactance over internal resistance equals 80 over 14 equals 5.714. An inductor has number 12, an inductor has a wire resistance of 6 ohms. The Q of the inductor is 9. Using the formula x of L equals Q times R, determine the inductive reactance of the inductor. So x of L equals Q times R equals quality equals 9, resistance equals 6 ohms, so x of L equals 54 ohms. And finally, number 13, an inductor has an inductive reactance of 150 ohms, a quality of 12, using the formula. So we have the formula R equals X sub L over Q equals 150 ohms over 12 equals 12.5 ohms. That's the internal resistance of the inductor.